This is a review of the mole ratio lesson that we did in class in advanced last week. Last week being somewhere around the 1st of February. We're going to take a look at a review for that. If you were in General Chem, this is actually a review a review of what we did in class today, and today is February 6th. All right, so let's suppose we have two chemical equations, and these are two separate problems. And I wanted to know if I were to be given, say, 12 moles of aluminum. And someone asked me, well, how many moles of hydrogen could you expect to have produced from that? So the question moles over here. So once again, that's just a problem I just made up. Suppose you had 12 moles of aluminum, and you wanted to know how many moles of hydrogen. What you would do to solve that is this. You'd say 12 moles of aluminum. Now you know that based on a previous experience with moles, whatever this unit is here, it always goes on the bottom here. And on the top, we put what we're looking for, and in this case we're looking for moles of hydrogen. You look at the balanced chemical equations to find the numbers that go into this ratio. So that's 3 in front of the hydrogen and a 2 in front of the aluminum. So our final answer then would be 12 times 3, which is 36, divided by 2, which would give us 18. Our unit would be moles of hydrogen, because moles of aluminum, you just saw me, cancel out. So in this kind of a problem, you look at this equation. The equation tells you the relationships. It tells you that 2 reacts with 6 to make 2 of these and 3 of those. And those numbers are always true for this equation, no matter what quantities you have. It's kind of like we know that a string quartet contains 4 players. And that's true no matter where you are. A string quartet is 4 players. But we don't know how many string quartets there are in the city of St. Louis. We just know that in one quartet there are 4 players. So the chemical equation tells you the relationships. The 12 that I started with was how many we have in this particular instance. So then you use what you're given in a particular instance and then get the relationships from the balanced equation. So let's try another one down here. Now you can do these kinds of problems between using any 2 substances that are in the equation. They don't have to be opposite sides of the arrow. They can be the same sides of the arrow. Doesn't make any difference. But we need to have the whole equation, because without the whole equation we can't get the coefficients, and the coefficients tell us the relationships. So the balanced chemical equation is necessary, but we won't use all parts of it in our problems. So let's suppose, for example, we had 90 moles of this. And someone said, well, I wonder if you made 90 moles of oxygen, how many moles of NaCl would there be produced as well? So we take our 90 moles of oxygen. That's what we're given in this particular instance. Be sure you write down moles of what, because that tells you that moles of oxygen must go on the bottom. But if you don't write the O2 down, then you get confused and you forget what goes down here, and then you start putting the wrong numbers in the ratios. On the top, you're going to put down what you're looking for, and in this case we're looking for NaCl. So put NaCl. Moles of oxygen, we know they're going to cancel out. All right, in the chemical equation we can see that when 3 moles of oxygen are produced, see that 3 goes there because the 3 is with the oxygen, we also produce 2 moles of NaCl. So now we have 90 times 2 divided by 3 equals 60 moles of NaCl. So if we were to produce 90 moles of oxygen, we would also produce 60 moles of NaCl. So that's where I'm going to stop this video, and I'm going to go to the next level. I just thought it might be helpful to review this. So this is a review of what we've done, and we're going to move on to the next level in the next video.